Today we're going to cover lesson 13-2. This lesson is still studying the idea of inequalities, but we're going to work with inequalities that involve some kind of multiplication or division.
The multiplication property of inequality for multiplying by a positive number states that if you multiply each side of an inequality by the same positive number, the relationship between the two sides does not change. If A is less than B, then A times C is less than B times C for all numbers A, B, and C, where C is greater than 0. For example, let A equal -5, B equal 10, and C equal 3. A number line can help show these relationships. -5 is less than 10. If you multiply -5 by 3, you get -15. If you multiply 10 by 3, you get 30. -15 is less than 30. Similarly, if A is greater than B, then A times C is greater than B times C for all numbers A, B, and C, where C is greater than 0. The multiplication property of inequality is also true for less than or equal to and greater than or equal to.
Okay, so it is true that we can multiply an inequality on both sides. When we multiply an inequality on both sides, if we do it with a positive number, our inequality will still be true. So we started with -5 is less than 10, and that's true. Well, we multiplied both of these values by 3, the same positive number. When we did that, our answers, -15 and +30, are now still, the first one is less than the second. The inequality remained true.
The division property of inequality for dividing by a positive number states that if you divide each side of an inequality by the same positive number, the relationship between the two sides does not change. If A is less than B, then A divided by C is less than B divided by C for all numbers A, B, and C, where C is greater than 0. For example, let A equal -6, B equal 4 4/10, and C equal 2. A number line can help show these relationships. -6 is less than 4 4/10. If you divide -6 by 2, you get -3. If you divide 4 4/10 by 2, you get 2 2/10. -3 is less than 2 2/10. Similarly, if A is greater than B, then A divided by C is greater than B divided by C for all numbers A, B, and C, where C is greater than 0. The division property of inequality is also true for less than or equal to and greater than or equal to.
Okay, so this statement is also true with dividing. And it is important, again, that we're dividing by a positive number, just like we're dividing by 2 on both sides in this example. If we divide by the same number and it's a positive number on both sides of an inequality, the inequality statement will still remain true. Okay, let's try an example. An elephant drinks at least 70 liters of water a day. Each trunkful holds 4 liters of water. How many trunkfuls of water does the elephant drink in a day? Write and solve an inequality. Okay, let's think about the words. So the elephant needs to drink at least 70 liters of water each day. Each trunkful holds 4 liters of water. And our question, how many trunkfuls of water does the elephant drink in a day? Well, each is a key word for us. It indicates that we're going to do some kind of multiplication. How many trunkfuls? That's the question. That's the unknown. So we should go ahead and give that a variable. I'm going to use n for the number of trunkfuls. All right, so we need to know we kind of want to work up to the total, like how much water does the elephant drink over the course of the whole day. Well, we know we're going to have to do some kind of multiplication. If it drinks 4 liters of water each trunkful, we can multiply that by how many trunkfuls it drinks, and then we should get that total amount. Okay, so the 4 liters each trunkful. And that should kind of total up to be at least 70 liters. So 4 liters each trunkful should total up to be at least 70 liters. Okay, 4 liters. Each indicates we're doing some kind of multiplication. We don't know how many trunkfuls, so we are using n. At least 70 liters. At least means that we want more than 70 liters, not less than 70 liters. And if you need at least 70 liters of water, it would be okay if you got exactly 70 liters. So we're talking about a value that needs to be greater than or equal to 70. Okay, now we can solve it. Now this is a multiplication expression, and so we would solve it by doing a division to both sides. We are dividing by a positive number on both sides, so that is okay, and that means that our inequality statement will still remain true. So let's see, 70 divided by 40. 4 goes into 7 one time. And 4 goes into, oh, hold on, I'm making a mistake. 4 goes into 7 one time, that's 4. And that leaves 30. 4 goes into 37 whole times for 28. That leaves 2 left over out of 4 is what we're dividing by. So 17 and a half, or 17.5 liters. So what's this tell us? Okay, n is how many trunkfuls. So our number of trunkfuls must be greater than or equal to 17 and a half in order for this elephant to drink the right amount of water. Okay, here's another example. A mouse drinks at least 0.042 liters of water a week, a lot less than an elephant. How many liters of water does a mouse drink in a day on average? Write and solve an inequality. Okay, so we need at least 0.042 liters of water in a whole week. The thing that is unknown, or the question, is how many liters of water does a mouse drink in a day? So maybe we could use D for just each day. The mouse drinks a certain amount of water each day or every day. Again, that's indicating that we're going to do some kind of multiplication. So the amount of water each day um, totals up to at least 0.042 liters every week. That's kind of a long way of saying that, maybe. But we know the amount we need altogether, the total. And we want our total to be at least this much. So just like last time, we want to get something that's greater than or equal to this total. The thing unknown is how much water the mouse drinks every day. Um, it might seem like the days themselves are unknown, but we actually do know how many days we're working with. This is talking about how much a mouse will drink in a week. So we do know that we're talking about 7 days. We don't know how much water the mouse will drink. Each is indicating we're doing some kind of multiplication. If we were to do 7 times the amount that a mouse drinks per day, we should get the amount it drinks for the whole week. And we want that amount to be greater than or equal to 0.042. Okay, so for solving, we have again a multiplication expression. We can divide both sides by 7. Our inequality statement should still hold true. We are dividing by a positive value of 7. So when we take 0.042 and we divide it by 7, which you can use a calculator to get this going a little quicker, we see that each day the mouse will drink 0.006 liters of water, or 6 thousandths of a liter of water. And that would be in order. I mean, the mouse could drink more than that, but that would be in order to meet the requirement for the whole week. Okay, so we've only been talking about multiplying and dividing with positive values. So let's look at what happens whenever you multiply or divide by a negative value.
The multiplication property of inequality for multiplying by a negative number states that if you multiply each side of an inequality by the same negative number, you must reverse the direction of the inequality sign to keep the relationship between the two sides from changing. If A is less than B, then A times C is greater than B times C for all numbers A, B, and C, where C is less than 0. For example, let A equal negative 1/2, B equal 3, and C equal negative 2. A number line can help show these relationships. Negative 1/2 is less than 3. If you multiply negative 1/2 by negative 2, you get 1. If you multiply 3 by negative 2, you get negative 6. 1 is greater than negative 6. Similarly, if A is greater than B, then A times C is less than B times C for all numbers A, B, and C, where C is less than 0. The multiplication property of inequality is also true for less than or equal to and greater than or equal to.
Okay, let's pick up in video number 2.